Hey everyone, welcome back to the last part of essential Python training. And in this part we are going to cover a lot of things like file handling, exception handling, standard libraries, debuggers in Python, magic functions, lambda forms, assert, decorators, memory management, etc. So let's begin. It's been some time since I have done this video, so I would like to remind you that in the last parts we have covered basic data structures, syntaxes, inputs, raw inputs, then iterators, generators, operators, control flow branching, looping, etc. And in the recent last presentation, that is on the fourth video, we have covered modules, function classes, meta classes, and various oops concepts. So let's begin. So what is file handling? File handling is like suppose you have a file in your local database, a simple text file suppose, and you want to write something to it or read the content out of the file, or you want to add something to the existing content, so that you and that you want to do with the help of your code. Like, you don't want to do it manually, you want your code to do that automatically for you. So Python gives you and that power to do that. There are three types of file operations. RWA, read, write and append. Read will only read the content, write will read the content as well as write the content from the beginning, and append will if you are doing write mode, it will remove all the contents of your file and start writing. But if you are using append, it doesn't remove the existing content and it starts adding new content to it. There is an extra mode of file operation, that is B, stands for binary. It will do changes in binary level, so it is more reliable. And there is you can using open keyword, you can directly open a file in Python and do various operations on it. But every time you use open, you have to explicitly close it. But if you are using with open, there is a statement called with open in Python. If you are using with open, you don't need to explicitly close the file. But if you are doing open and you are not closing and you are trying to do another operation, that might cause your system to corrupt your file, so be careful. So I'll give you a small demo. This is file. Okay, I have write a block of code here, and this is, it will print default, it will open a file, it will read where the lines of lines written in the file, it will print those lines, and it will close the file. Then this is the default mode. Then with using R, I'm doing the same thing, but it is with read mode, which is basically same as the previous. Then I'm doing like I've commented this to because if I do this, it will just remove all the content. So in the runtime only I will uncomment it and show you. Then this is another content, which is append. It will append a new line to your file. And this is an example which will give you the overwrite content. Like, it is basically the same as this, but I'm just putting it at the end, so you can see like how it is working. So let's and 1 minute, my file is this, which is present in the current directory. It's written, hi everyone, here is some random text present here, and I'm using the file name here. Actually you should use the full file path, but as the file is present in the same directory, I'm not using the full path, and it should work. Let's see, Python file.py. it's saying default. Hi everyone, here's some random text present. It is because of the default behavior. This is because of the read behavior. Then this is attempt to write in read mode. So which is commented, it should not do any changes. Then it is append and overwrite. It should first append it, then overwrite it. Now you should see only one line of code here, which is Steve Rogers is a captain. If I do this, suppose I type something and save it, and I go here and I comment this and I execute it again, you should see two lines. Okay, let's let me see. Oh, actually I have opened it in write mode, so it's removing everything. As you can see, after this it is adding a new line here, means a new content here. But if you are trying to, if I try to just open it in write mode and just execute it, it will clear the whole file. Then if I just uncomment this write block also and execute the file again, it will write a new line here. So this is how our file handling works, and you can use it in real-time programs. Let's move on to the next slide, which is exception handling. Exception handling is something like suppose some error is occurring in your application, and that is breaking your application, but you don't want your application to break. You need your application to be stable. Just imagine, like suppose you are using a web application and you are sending a request, like some button you are clicking, or you are clicking on sign in or something, and your response doesn't get back. It broke down in your server and it doesn't comes back to you. So that doesn't feel good, right? Means even if some error is there, you should at least see that this error has happened over the server, and we will take necessary steps or something, or some other messages, but it should return some response to you. Same way, like suppose you are if I do this, suppose I is a blank line, J is 7, sorry. If I do K is int of J, which will be equal to 7, so it's typecasting J into int. But if I do the same with I, so it's actually breaking. It's saying value error, invalid literal for int with base 10 for the space I have given. So there should be something to handle these things. So this is just an example I am giving you. There may be some other issues which need to be handled, so that you can do using try block. Just how to do that, just write try, then write k equals to int of I except print cannot convert string to integer. So it's showing cannot convert string to integer. So and as you see, previously it was showing some error, it was breaking, but now it is just printing something. So this way you can also return something and show that message for your user. So this is a better way of doing things. So I have an example for you, like to show you how except works, like just the syntaxes. This is the error that I have already shown to you. and this is I'm trying to execute some file which is not present here, but it should maybe work. Let's see. And this is right, I'm trying to write something to that file. So let's see. Python except some error occurred, so it's coming here because of this int. Let me just comment it and check again. Written content in the file successfully, and as you can see there is a test file created here automatically and something is written here. So this thing is working, this file operation. But if you want to see the real error, you can just put like this and do this. One thing I would like to say that you can use multiple excepts in with and try. Then you can use else with a try, the way you can use else with looping, like with for and all. If no error occurs, it will come to else and it will close the file. Similarly, if in other cases also, if no error occurs, it will come to the else part. And you can use finally here also. There is a keyword finally, which if I do print, if I do this, I don't know what error it is showing. Okay, some indentation problem. I'll fix that. Okay, let's see if I can do this. You're seeing success here. So my point was, like, you can use finally with any try, and whether or not you encounter an error, whether or not it is a success or anything, it will finally come into the finally block. So, and that is how finally works. Okay, let's go to the next, which is standard library. I'll come to standard library after some time in the end maybe. Let's move on to debugger and magic functions. Like every other program, we have debuggers in Python also. What does debugger do? It adds a trace to your file, and you can just execute your code line by line to check what is actually happening. So let me show you the syntax. If I do here import, the Python debugger name is pdb, Python debugger. Then I go and then I put here pdb dot set underscore trace. This is a debugging, this is a trace back function. If I just go here and try this, now it is showing me try, which is the next line here. So, and it's asking for input from me. If I type C here, means continue, and it will continue and it executes the whole file. But if I want to see the file line by line, I just need to type n for next. It tries executed and it goes here. It's showing this this line, and then I again put n, and it's showing some error has occurred. So it will now go inside the except block, which is saying except IO error. This is not an IO error, so it will just skip this, and it will go except value error. So as this is a value error, it will come inside this, and it will print this. Then it will go inside the finally block, which is return success, and it's print success, and it get out of the execution. So this is how PDB works, Python debugger, and you can dig into it more on Python site, like what are the various other functions. But I think you don't need any other function. With set trace only you can debug any big programs. Then we have something called magic functions, like any function followed by double underscore in a class is known as magic function. Like the one you have seen, like the init method or the del method, they are constructor and destructors of uh, a class. They are not called directly. Whenever you try to instantiate a class, init is invoked. Whenever you try to call the del, the delete, that under del is invoked. Similarly, there are a lot of other functions like lt, gt, less than, stands for less than, greater than, and many other functions. Those are called magic functions. They can do, why they can add magic to your classes. They are not going to be get called the way they are written, but the code is going to execute the way it is written inside. Okay, so let's move on to the next slide, which is a lambda. Lambda is an anonymous function. Let me see if I can show you some example. It should give me output 30. Okay, there's some issue, maybe some syntaxes I have given wrong. So my point was lambda. I'll get back to you in the next slide on lambda, like on the details about lambda. But how lambda is used? Lambda is an anonymous function that is used to, like, suppose you are using lambda inside some function. So the first argument to that function is itself is a function. The way I have done it, like, this is a function. I have used lambda inside, and I have used x and n. I have passed n for 5 here, and I have assigned it to z, and I am passing a second parameter here. So the first parameter to first function is a function to the next function, and second parameter is the second function here. So this is how it works. Then it comes map, reduce, and filter. There are three very important things are there in Python, which we do not use on day-to-day life, but if you go for big data technologies, this is very, very, very important. So what is it? Like map, reduce, and filter. Using map, a data set, like a list or something, a data containers can be mapped to a function like the below code you are seeing. Like I have assigned items, then I have defined a definition, then using map I'm passing the function name and data set inside that map, and I'm creating a list out of it. Same way, so what it is doing, it is going to create a new list with square of each element of this list. So it is type of mapping all the elements to its square. But if you try to do a reduce, what it will do, so here you can see I'm using a lambda. It's like suppose I'm using reduce, and this is one list I'm passing. What it will do, it will just multiply one element with the other. It will keep on multiplying, and finally it will give you the output. Sorry. And in the second attempt I am doing it with a list. Just let me show you the real example. This is a map, the same example that I have shown you. Let's try to execute this. Then map. Now you can see it's 1 2 3 4 5, and the values are 1 1 4 9 16 25. If you go to reduce, this you can see it's just multiplying first element with the new element. What lambda is doing here is it will just multiply one with the other and put it as y, and the next element of the list is going to be as x, and it will multiply again. This way lambda works. So let's see how it's working. Reduce. I have multiplied 1 2 3 4, which is 24, and I have added 1 2 3 4, which is 10, using lambda, and reduce. Same way we have filter. Filter is mainly used for filtering the required value from a data set. Suppose I have not given an example here, but I will surely give in the last slide. Suppose I have a list of data and I want to filter some values that fit some criteria of my execution. Then using filter you can do that. Then we have something called assert. Assert is mainly used for testing purposes. What the work of assert is, assert by default is always true. If any value except true is there for assert, it will not work. Let me show you an example. Like if I do assert true, it will not show me anything, but if I do assert false, it will show an assertion error. If I do assert false error with a comma, this will give me the message here, which is I am passing here. If I now try to do this, assert int comma unable to convert int to string to int. Okay, it says okay, sorry, I'm just converting it, that's why it's showing. If I do type is int, unable to convert string to int, it's saying the message, and it's raises and asserts an error, which can be which you can handle with your exception, or generally it doesn't need to be handled, because usually what we do is we handle all these things with, like, we want this error to be happen because we are doing a testing, and exception is mainly used for testing purpose only. Okay, so let's move on to decorators. Decorators allow you to make simple modification to callable objects like class, function, methods, etc. Let me show you one example. There are many ways you can define a decorator in frameworks, in various frameworks like Flask, Django. They give their default decorators. You can use wrapper classes to create your decorators, or you can just use their decorators also. Let's see what we can do by ourselves. Suppose I have given foo, and I have created another function inside that, which is bar. I am printing 5 here, and I am returning bar here. Sorry, it should not be return, it should be an execution statement. So if I execute foo, it should okay, I have just missed an R. If I type foo here, it should print me 5, because like as I said, every thing in Python is an object, so there should be a class related to that object in Python. So whenever you are declaring one function, you can define other function inside that and return it or call that function for execution. This is how our decorator works. Like, you can create some action function and bind that action function on top of any other function that you have, and whenever you execute it, your first request or arguments or anything, your flow variable goes to that function, that action function, or which is a decorator, and then it comes back, and then if it satisfies all the condition written in that function, it comes back to your function. Okay, let's sorry. Okay, the next function is the next topic is memory management, like how memory is basically managed in Python. So what basically happens is, we have a private heap containing all Python objects that are created during your runtime in your at the background of your compiler, which programmer has definitely no access, and the allocation of objects from that heap is done by Python memory manager automatically. And but there are some default garbage collector also present in Python. Suppose you want to do some garbage collection techniques by yourself or manually, you can use the library, the GC, which has GC enabled, GC dot collect and lot of other function. You can use them. So basically my point was, you don't need to use any functions like calloc, malloc like C to manage memory in Python. That Python does it for you automatically. That's why it is known as a high level language. So that's all for today class, and we are done with the Python essential training. There are many things that I have missed, and there are many things that I haven't just told you, and like how actually decorator works, how lambda forms works, and lot of other things. In the next slide, we are going to have a wrap up slide which contains all the things that I have missed in the whole training, and we will wrap up everything in that training. And I promise, you are going to have all details of this programming language, and you will be able to write good code with this. As of now, you should be able to write good code, and if you are not able to write good code, you can contact directly to me, and I will help you write good code. So that's all for today. Thank you.